So we finished the last session with a viewpoint framework, which is an important conceptual framework for our course because it describes all the models that we are going to use for designing our products. Before going to modeling, I would like to talk about the concept, the notion of model. Well, in 1 hour or so from now, you all will be modelers. So you are going to model your great ideas using goal models of agent-oriented modeling. But before we can go to that, I will cover some important notions which are necessary to know before you can start modeling. And the first of such notions is what is model in your view? And again, this is the place where I expect you to come up with some ideas about what is model. Again, it doesn't need to be specifically IT oriented, but in general, what in your view, what is model as such? Yes, some sort of representation of a real system, yes. So any other ideas? How would you characterize that representation of a reality? Well, it's true, it is some kind of representation of a reality, but what adjectives would you use to characterize that representation? Yes, yes, this is true, not fully functional. Yes, yeah, exactly. Simple, this is one of the keywords I was looking for. Simplified representation of a reality that is not fully functional, but can still mimic some functions of a real system. So any other ideas? So basically a simplified representation of reality is a general definition for a model. Hypothetical simplified description of a complex entity or process. So how complex or simple does a model need to be? So we agreed that a model is a simplified representation of a reality, but how simplified? The simpler, the better?
Simple enough to describe what you...
Yes, yeah, simple enough to describe what you need to describe. Yes, and there is a good saying about this by David Lodge Parnas, saying that a model should be as complex as it needs to be, but not more complex. So, in other words, we do not need to create complex models just for the sake of those models, but we need to create as complex models as we need for the purposes of designing our system, which in the given case is the product that you would like to design. And we can also explain it in the way that certain features of a phenomenon or entity to be modeled should be ignored, and some other features should be addressed by the model. So we should always pick out important features for the purpose of our system or product to be created. And there are some examples of models. A very simple one is a model of a solar system. And I think that many of you have created this kind of model as a part of your high school, secondary school curriculum. And there can be different models of a solar system. It can be a very simple one, can be a static one that just gives an idea of the sun and different planets and the distances between the sun and the planets, or it can be a more complex one where planets in a model they actually they revolve around the sun resembling the real solar system. Then the model of a gold mine is an interesting one. When I lived in Melbourne, Australia, then I went quite frequently with my family to the Melbourne Museum. And in one spot in that museum, I noticed there was a model of a gold mine, because the area of Melbourne, the surroundings of Melbourne in the state of Victoria in Australia, is where actually gold was found in late 1800s. And that caused a local gold rush there. So as a result, many people went there for gold. Many people that were actually hoping to find their fame and fortune through finding gold. And the first thing that the newcomers actually they had to do, they had to learn about this gold mining business. And this is why the model was created, because the model was created to introduce newcomers to the gold mining business. So it represented different layers of a gold mine, different mechanisms, equipment that was used in a gold mine, so that this could be demonstrated to a newcomer, and a newcomer could be then could more easily understand what was going on in the gold mine. And this was the example of a model as a simplified representation of a gold mine. And that model is quite old, and it was a predominantly static model, but also some parts of it were dynamic, that were able to move. Some mechanisms, equipments that were used for mining gold, they are also they were moving, so that the newcomer could see, I mean, how it actually works. Then I've also seen in museums models of chemical plants, and some of them actually functional. Because when someone needs to put up a complicated chemical plant, then it makes sense to try it out first as a model, and also to try out chemical reactions to see if it really works. So I've seen such models in different museums. And this one here is an air traffic simulator from a very early era, I think from 1920s or something. So then this kind of analog air traffic simulator looked like this here. And of course, current contemporary air traffic simulators, they look quite different. Modeling is an important topic in a software engineering community, and the language that is used for modeling in a software engineering community is UML. I think those of you with the IT background, then you certainly have used, or at least you are aware of UML. Well, why are models needed? I think I already hinted. In many cases, we need a simplified representation of a complex entity or process in order to understand that entity or process, or in order to design a complex system that we model as the first stage of the design. Well, some good examples about models are that, for example, a handy person can build a shed in his or her backyard. It's not well, it takes time, but it can be done. But the same person cannot necessarily build a 30-floor office building. And in case of the 30-floor office building, the models are absolutely required. The models as sketches, architect's plans, then plans for different contractors, like for plumbers, for electricians, builders, internal works, and so on. And another example, that a scientist can write a program to do some calculations, but can the same scientist necessarily do program and air traffic control? About systems engineering, this is what we're going to do here. We're going to engineer, design our systems as products. And the systems engineering is the process of specifying, designing, implementing, validating, deploying and maintaining socio-technical systems. And there is a clear analogy here to constructing a building. Because in case of a building, just like in case of a complicated software system, we need to do sketches first, then the architect's plans need to be done, and then this has to be followed by contractor's plans for plumbing, electricity, and so on. And generally, there are three perspectives to engineering any kind of system, be it a house, 30-floor office building, or be it a transportation system for a city, or be it a complicated information system. So, and these perspectives are the ones of the owner, of the designer, and of the builder. System lifecycle stages, I mean, this is a classical stuff from software engineering. We start with requirement solicitation and analysis, continue with design, decide the architecture, do detailed design, implement, test, and maintain. And these days it is done actually in an agile way, meaning that we do not do all of the requirement solicitation and all of design at first, but we do some of it, some of design, some of implementation, and we test right away. And then we go to some other feature of the product and do the same. So we go by features of the product to be, or of the information system to be. This is the conceptual space for agent-oriented modeling. It reflects the perspectives of owner, designer, and implementer. And the process of design is actually moving from the owner's perspective to the designer's perspective, and the process of implementation is moving from the designer's perspective to the implementer's perspective. And here are shown some concepts that are relevant for agent-oriented modeling. They are described in detail in this book. So I'm not going into all of these concepts, but only to those of them that are absolutely necessary for our modeling exercises that we're going to do today and later this week. And as you can see, there are potentially complicated relationships between these concepts at different layers. So what are these relevant concepts for our course? So I will introduce them step by step, depending on the need. So today, as we are going to create a goal model for your product ideas, so I will concentrate on the concepts that are absolutely necessary for creating goal models. And now, so I ask for your attention, because in half an hour or so you're going to do it by yourselves. So, and in order to do it in the correct way, so you really need to understand what these concepts mean. Well, let's take the concepts of goal and role, and we will address domain entities tomorrow. So, what is goal?
Target.
Target, and maybe more specifically? State of the system to be achieved.
To be achieved, yes.
Yes.
The main intention behind whatever I want to do, what I want to get out.
Yeah, the main intention, whatever. I mean, whatever I intend to do. Yes. The result. Yes. End result. End result that I aim at. Yes. Mm-hmm. Any other ideas about a goal? Just a goal, again in the everyday sense. So I'm not referring specifically to information technology, but just a goal in everyday life.
Sometimes goal is a process of certain actions.
Yes, but the goal obviously is some kind of state of affairs where you intend to go, where you intend to get through that process.
Yes.
Yeah.
Right.
Yeah.
Right.
Yeah.
Right.
Yeah. Any other ideas about goals or related notions like desires or intentions?
Maybe a measurable state in the future.
Yes, yes. Yeah, measurable is actually quite a good term here, or quite a good adjective. Yeah, measurable state. Yes, but state of the future, definitely. Oh, any other ideas? So do you use the notion of goal in your everyday life? Do you speak about goals to be achieved? To achieve a diploma, for example, to graduate? Yeah, I think it belongs to everyday language of almost everyone. Yeah. Yes. So, what about this one? Dream with a deadline. Do you agree with this one? Is this a goal, or is it maybe too poetic an expression? Well, actually, I've noticed that when my students have taken exams, then in many cases the only thing they have actually remembered about goal modeling is this definition, and it is almost right, but maybe not quite. So the goal is actually a particular state of affairs intended by one or more agents. So as you said, and you said, it's definitely a state of affairs. Measurable is a good adjective here. It's always good if we can measure the goals to be achieved, even though it's not always possible. But it's still good feature to have. And the thing I would like to add here is that this state of affairs is to be achieved by one or more agents, or by one or more actors, by one or more active entities. Be it humans, be it software agents, robots, I don't care. Just there always have to be some agents, some active entities that need to achieve certain goals. And now we divide goals into functional goals, and functional goals are about things to be done. So functional goals, they are usually represented as verbs, to do something. For example, to deliver a lecture in the summer course. So I'm now delivering a lecture in the summer course. This is the process, by the way. So I'm in the process of achieving my goal to deliver this lecture now, or seminar, as maybe it's a better name. Yes, and this is my goal. But I achieve this goal through a scenario, and this is what actually I'm doing right now, or I'm involved in this scenario. But it's not just me, not just this agent here, but also all those agents here, that are involved in this scenario, meaning that these goals are, in most cases, are achieved through interactions that are represented as scenarios. So because we here interact in one way or another, so we are involved in a scenario. Or attend the lecture from your perspective. So you attend this lecture, or you attend the summer school. Better, you attend the summer school. This is your goal, and this is measurable goal, because after you will finish this summer school, well, you will get some sort of certificate. Maybe not, you will not be marked. I don't think so, but you will get a certificate, and actually this will add something to your CV, and it's always good to have to actually graduate from summer schools, especially from the one from the Innovation Academy of Tallinn. Yeah. So this is your functional goal now, to graduate from this summer school. Then, in addition to functional goals, we always need to talk about non-functional goals or quality goals, because they are very important qualities that always need to be modeled about systems to be developed. And this varies. It depends on the area where your product to be is in. But it is relevant for most areas. For example, there is one, I remember there is one product about smart insurance here. and this is the quality goals play an important role there, because it's about really how individual drivers, how they perceive just treatment, in the sense that, well, I may be a good driver, but I still have to pay a very high premium. But if my premium would depend on my actual behavior in the traffic, then I would perceive this as just, this meaning that just is an important quality goal here. It is, I feel this is just towards me, because I'm treated the way I deserve. So I don't have to pay for actually other people's sins, but actually I just, the premium I pay just depends on how responsible driver I am. And also the system about social networking for pregnant women is the one where quality goals play an enormously important role, because it's actually, it's not just about discussing different stages of pregnancy or exchanging ideas, but it's a lot. There is a lot about emotions, actually, about emotional states and sharing at the emotional level between each other. So quality goals are very important, but they are, unfortunately, they are often ignored by software engineers. And actually, at this stage, I would like to show you one video clip about engineering quality goals in software engineering. So, how was it? I mean, did it affect you, or what sort of impression did you get?
It's very emotional.
Yes, very emotional. Yeah, exactly. This was the goal, because it was about emotions in software engineering. Actually, the lack of emotions in software engineering so far. Because when software engineers talk about non-functional goals or about quality goals, then actually in most cases, they address issues like security, reliability, robustness, and things, more issues of a more technical kind. But they almost never talk about issues that are related to emotions, like, for example, having fun. I mean, definitely, this is, for example, considering this giving a lecture here, or giving this teaching in the summer school. I mean, this having fun is an important quality goal for me as well as for you. So, I mean, it shouldn't be overly serious, but I mean, we should have fun together. Usability.
Yes.
Uh,
Can we say that feelings can go there?
Yes, some of the feelings can definitely go there. Yes, usability, because it's about user interface. Yes, I mean, it has to relate to feelings. But on the other hand, again, I mean, I'm referring to that example of pregnant women supporting each other. I mean, then we should also consider quality goals when engineering interactions. So it's not just about user interface, but it's about also what kinds of interactions the system would support. We should consider quality goals there. Or, for example, when we talk about engineering games, then on one hand it's user interface, but on the other hand it is what is actually going on there in the game. I mean, how are our emotions involved? How does it affect our emotions? So it's not just about user interface. It's user interface is just a part of the story, but another part is really what is the game about, and the game, going through the game, playing the game. I mean, how does it affect our emotions? So that video clip was made in Australia by one of the PhD students of Leon Sterling, the professor you are going to see tomorrow over video conference. And that PhD student is dealing with designing digital products. And the digital products in his case, they are actually games. But they are not just games for fun, like you have probably come across such games for fun, I mean, predominantly. But they are games that have a deep educational purpose. And for example, there is a game that is meant to promote tolerance in a society against people having some form of autism. So, because usually, or against people who have Dawkinson's syndrome and things like that. So, because usually people tend to be intolerant towards such people, but through playing a game that is aimed at increasing tolerance, the situation can improve. And I think that in each country there is a need for this kind of game. I mean, because there are certain groups that people tend to be intolerant towards, like people of different skin color or speaking a different language, and also here in Estonia there is a need for games of this kind. So quality goal is a quality requirement of the system to be. And usually a quality goal is characterized by some kind of adjective, like for example here, attentively. While functional goals, they are represented as verbs, like attend the lecture. It's a verb, attend. Then quality goals are represented as adjectives, attend the lecture attentively. Listen to the lecturer attentively. And quality goals in some cases can be measurable, but in some other cases not necessarily, because how can you measure having fun, for example? I mean, it's possible. I mean, you can have some groups of people and you sort of measure their reaction somehow. Using some psychological tests, but in many cases, it's hard still, despite there is seemingly a way of doing that. Okay, and another notion that is important for the exercise we're going to do pretty soon is role. So, what is a role? How would you define a role? So again, I'm trying to trying to provoke you a little bit. So what is role? Function, you would say?
What's, how you interact with the system as a user, as a manager, as an IT specialist?
Yes, yes. Yep, from the perspective of using the system, yes, the way you interact, yes. Yeah, exactly, yeah. So any other ideas?
A group of tasks that are for one person?
Yes, yep, yeah, the roles, they in one way or another define the tasks that a person has to perform, yes? So we talk actually about responsibilities. The roles are represented in terms of responsibilities, yes? Any other ideas about roles?
I would say behavior.
Behavior, yes, behavior, yeah, it is indirectly captured there, but it's not yet about behavior. It is more general than behavior. Yep.
Different division of work maybe between different areas.
Yes, yeah, exactly. This is very important. I mean, through roles we can divide the work from the very beginning. When we design our system, then we divide the work through deciding roles and then later on assigning agents to those roles. Yep.
It's a job function basically.
Yeah.
It's not just describing this responsibility. It's
Yeah.
also the
Yes.
maybe the authorization, for example.
Yes.
Like because role is a general term.
Yeah.
Other roles we can assign users.
Yes.
It will help
Yes.
us
Yes.
to
Mhm.
change, like to edit our
Yeah.
models or
Yeah.
systems
Yeah.
very
Yeah.
easily.
Yeah. Yes. Yeah. Any other ideas? A role can be defined as some capacity or position that the system requires in order to achieve its goals. So here you see a role is related to goals, because when we build a system, the system has a goal. I think we agreed here already earlier in the morning that a system always needs a purpose, and the purpose can be divided into sub-goals. But then we also need someone or something that would achieve these goals set for the system. And we represent that someone or somebody in an abstract way through roles. And we are doing it in the analysis phase. And later on in the design phase, then we are going to map these roles onto agents, either humans or machines or software agents who are going to play those roles. But this is the topic for Wednesday, I think. But the role is some capacity or position that the system requires in order to achieve its goals. And well, you already brought some examples, but some examples from everyday life, like for example, I have different roles as a lecturer, as a researcher, as a husband at home, as a parent at home. So they are all different roles. And by the way, professor is not a role, but it is a position. And position is actually a composition of different roles, because it consists of different roles, like a researcher and a lecturer. So they are all different roles that all make up the position of a professor. Okay, domain entity, we're not going to talk about them tomorrow. And now, closer to our exercise. First, again, the viewpoint framework. You're going to see it a lot, throughout this week, I can assure you. So that I hope you will know it by heart at the end of our course, just as you should know the business model canvas by heart by now. And now we are here, meaning that we address the perspective of behavior of the system at the level of problem domain analysis. So this is where we are right now. And we are going to create goal models. And a goal model is basically a hierarchy of goals, starting with the purpose of the system to be. And the system to be is the product that you're going to design. So you all teams have some idea of a product, and now we're going to design that product, starting with the purpose of the product. So there is a hierarchy of goals. Then there are roles associated with goals, meaning that we need roles to achieve goals. Then we should, in our model, we should always relate roles to the goals. And if we connect some role to a goal, then this role is required for achieving that goal and its sub-goals. I will come back to this. Quality goals attached to goals, meaning that, for example, if there is a goal, give the lecture, and there can be a quality goal attached to it, to do it in the way that it would be fun, or let's put it simpler, just to have fun. And now, I'm not going to talk about use cases at all, because I think goal models are a lot better than use cases. Actually, in fact, I hope that goal models will replace use cases at some stage. Why? Because use cases are meant for closed systems, meaning that from very early on in use cases we define the system boundary. We just decide that, okay, here is the actor and here is the system. With goal models, we are not going to do it. We are going to postpone designing the system boundary, as much as possible. Why? Because we are talking about open systems. And in open systems, everyone can enter, and everyone can opt out at any time. And even more, in open systems, it's not easy to actually even distinguish a system boundary because they are socio-technical systems, meaning that humans also form a part of the system. And this is to say that we all form the system. It's not that, okay, here is the user, here is the system, but we all make up a system. And this is particularly true for social information systems. We all make up a system, and anyone can join the system or leave the system at any time. So no use cases here, but instead of use cases, we use goal models. And now, some examples so that you will know how to design, how to create a goal model for your product. Tamagotchi. The purpose of this system consisting of humans and Tamagotchis. So I'm not talking about just this Tamagotchi. I'm not talking about its environment only. But I'm talking about a system that is made up by this box, the Tamagotchi with its environment on one hand and its owner on the other hand. And in addition, there can be other Tamagotchis and their owners. So this all makes up a socio-technical system. So the purpose for this socio-technical system is entertain and educate owner. Okay, let's put it in a bit different way. Let's imagine that this Tamagotchi hasn't been invented yet. And we are in the shoes of someone who has invented it, who has created a business model for it, and who is now going to design this digital pet. So the person obviously has to start with the purpose of the system. And the purpose would be the entertain and educate owner. So two components, entertain and educate. And the quality goal is the owner has fun, because otherwise the kids, children would not use it if it would be of no fun. In this sense, it's a very good example. It shows how important is fun and emotions. And then we also show here that there are different roles related to this purpose. We need the role of owner. We need the role of my Tamagotchi. Just the role of my digital pet is my Tamagotchi. And now this actually, all this here makes up a value proposition, because the value of this product is consists or the value is entailed in entertaining and educating owner, so that the owner would have fun. and the stakeholders are the owner and my Tamagotchi. So did you get me? So the value proposition is to entertain and educate owner so that the owner has fun. And now the sub-goals show how this should be done in more detail. So this is the idea, the value proposition for a product, and then detailing it in the form of sub-goals. So, and how do you do it here? Well, you need to sustain your Tamagotchi, you need to keep it alive, you need to feed it, you need to socialize it, you need to play with it, and so on. And here we have a quality goal about user interface, because as someone mentioned here, user interface is definitely important when modeling quality goals. So, and here it is particularly important because this is used by kids mostly, and the kids won't use it if the user interface would be too complicated. And then in more detailed level, there are sub-goals, each representing a specific aspect of achieving a higher level goal. So the meaning here is, you sustain your Tamagotchi, and then there are different aspects of sustaining your Tamagotchi. You need to feed it, you need to cure it, you need to clean its environment if it makes a mess, you need to socialize it, you need to entertain it, you need to discipline it. And then there are quality goals related to them, like my Tamagotchi healthy, quality goal related to these 3 functional goals, my Tamagotchi happy related to those 2 functional goals, and discipline, and my Tamagotchi well behaved related to discipline. And of course this is from the perspective of children, it's natural, but but as you know, this market for Tamagotchis is huge, and they have become a very popular tool because someone came up with this kind of value proposition that is modeled here. Another example is societal grocery shopping. And okay, we have still a few minutes before we start our exercise. So here, the purpose of the system is perform shopping. Then the value proposition. Okay, let's say the purpose is perform. Perform shopping. Then there are 2 quality goals: societally. Perform shopping in a societal way by relying on information gathered by other people that I can use for my shopping, and perform advantageously in the sense that the overall cost for my shopping basket is the most advantageous possible, the best possible overall cost, because I would like, everyone would like to minimize her or his costs for life, and here this is represented through this quality goal here. And then there are roles related to it, like customer's assistant, which later on you will see it will be played by a software agent and a store. And again, this functional goal together with those quality goals, societally and advantageously, they actually make up a value proposition. So in other words, the value proposition here is to come up with a system that helps to perform shopping societally and advantageously. And then these roles represent the stakeholders in such a system. So it's all related to stakeholders. I mean, all related to value propositions. And again, here are sub-goals representing different aspects of this kind of societal information system for grocery shopping. And like join the system, create shopping list, find potential stores, decide store shopping baskets, decide the route to different stores, buy products, exchange price and quality information. Yep?
The question is about quality goals, yes, and functional. What if we have a quality goal that heavily affect the function? For example, delivering flowers from Holland. You know that if you don't do it within 1 day, then the value of the flowers is zero. So how it will,
Yes.
can you explain?
Yes, this is a very good example of a quality goal, by the way. If we have some sort of a delivery system, some sort of socio-technical system for delivering flowers from the Netherlands, then, well, definitely we should model the functional goals, which is deliver the flowers, yes. And then, I mean, very important quality goal here is do it quickly, because, I mean, and despite the refrigerator cars, still need to do it quickly. But then, of course, they affect you how you design the system. But right now, when we are doing analysis, so we are not dealing with this actually particular consequences of that in terms of architecture and design. But the very reason why we need to actually take note of this quality goal quickly here is that we can address it later on when deciding the architecture and when doing the architectural design and detailed design. So this is why it's very important to actually take note of such things so that we can actually address them later on. But we do not address them right away, because if we come technical right away, then it will become very confusing, especially for non-technical people, for stakeholders, like for example the like this big flower merchants. So because they need to be involved in such a system. So and it's quickly, it's important, but how we're going to do it actually in terms of technology will be decided later on. Yeah, that was a good question. Thank you. Yeah.
Just to follow up on his question there, if you have fresh flowers in two shops, one is fresh, one is not, one is 2 or 3 days old, you can't be guaranteed as a customer that you're going to get the 1 day old or the 3 days old.
Yeah.
So you're talking about quality there, quality perception. That's why I'm very skeptical about how you can compare 2, 3, 4 shops together, because produce varies in quality from shop to shop. Delivery service varies from shop to shop. Attention for detail varies from shop to shop. Customer service varies from shop to shop. So really, I don't see how you can make this very scientific comparison between 2 or 3 locations.
Yeah, well, we can actually do it by relying on customer feedback, for example. But again, here the purpose is to just take note of such quality goals. To actually take note of the very fact that the quality of services is important.
As an example, what you mentioned earlier on about the economics, like one store, the cheapest store might be 20 kilometers away. Whereas in America, that's no problem.
Yes.
But in Europe, that's a very critical point.
Of course.
And the store that's 20 kilometers away is not practical. It's more practical to pay more money downtown Tallinn and get it to your home.
Yes, of course. That product idea originates in the US, of course. But yeah, of course. But even here, I mean, I think at some it can work actually at some places. I've noticed it myself. I haven't tried out this kind of system, but just manually, so it can even work. Especially in like suburbs of Tallinn, maybe not in the center, but in suburbs where people are used to driving around. For example, where I live, there is no other way than just drive everywhere. But these issues, it's important to actually take note of such issues in the form of such models, for example. So it's very important. These are very important factors that you mentioned, the both of you. So we should actually take note of such things, and then later on we're going to address it in design. How can we support the comparison by technical means? I mean, can we rely on some feedback by customers? Price is a very objective criterion, but quality, I think, feedback by customers. But yes.
This is a very good question. What you mentioned there about feedback by customers, I think it's very important in the likes of this business model, especially consumer-driven models like Food Basket, for example. But aren't you a little bit skeptical when you look at the travelers' websites, for example, TripAdvisor.co.uk, TripAdvisor.com, that you get a Finnish person who goes to a particular hotel in Tallinn and has a Finnish perspective on the whole situation. For example, maybe they love the water sports, the hotel and it gets 5-star rating. And you get an American tourist comes in, the service is crap, water sports are great, and the American gives it like a 1 star. So it's it's not very objective. I don't think so, because humans don't work like software. Humans are based on emotions and stuff like that.
Exactly.
So,
yes.
And every
yes.
different cultures are looking
yes.
for different things. The Estonians are looking for
exactly. But
so
yes.
How do you make a model that's guaranteed to be accurate?
Well, you know, with such things, there are no guarantees, but still, I mean, I need to capture, namely those issues, I mean, for cultural issues, as quality goals, because whatever. Usually, I have some actually target market on mind, so I should then represent this cultural features of the target market through quality goals. So this is the idea. But these are exactly the issues that need to be modeled and captured explicitly, because in many cases it is not done explicitly. And the systems, no one will use these systems, because they are like meant for local people, but even Finns fail, not to mention Americans, using these systems. Yes, so these are very important issues. Even when designing websites for tourists, such quality goals should be explicitly modeled. And again, in most cases, it is not done. And again, it's related to emotions.
One of the problems I find with technical systems, mechanical, electrical, electronic, and software, is that these gurus of software developers are excellent in their craft.
Yes, yes.
Very few of them look on the other side and use it as a user from the user interface perspective. They're looking at it from the top level, but none of them are looking at it from the ground level.
Exactly. I totally.
You get systems that don't work properly.
Yes, I totally agree. This is why I'm actually talking so much about quality goals here, and you will hear more tomorrow, from Australia, about software quality from this perspective. It's very, very good points. So any other questions at this stage? Okay, then just one more example, and this is about increasing respect towards people having a kind of syndrome. It's called Asperger's syndrome. It's basically a kind of autism, and then the game was developed for that. Just a game. Game that that didn't have explicit agents. Well, it wasn't a multi-agent system in the strict sense, but still this modeling notion of agent actually made a great sense here and was used here with a great success. This developing this game started with this goal model. As you can see, the purpose is Asperger's respect. Increase Asperger's respect. And then there are quality goals. Increase it in the way that it would be educative, and increase it in the way that it would be fun. And as you can see, there are now different kinds of quality goals. To be quality goals, be educative, and to feel quality goals, emotional quality goals, like feel fun. So this is a very important distinction. And this all this actually makes up a value proposition. To increase Asperger's respect in a society so that it would be educative and so that people would feel fun through playing that game that aims to increase the respect towards the people with Asperger's syndrome. So this is the value proposition. And by the way, the guy who has developed the game, who has also developed this model, is very, very well known and respected in Australia for developing these kinds of games for social purposes. And then there are sub-goals, I'm sorry for the quality, but promote tolerance, promote communication, promote social inclusion, reduce bullying, and then the respective quality goals: emotional goal, feel responsibility, be empowered, be clear and truthful, feel empathy, and so on. And then the roles are neurotypical teens, teenagers, because it's targeted at teenagers who have actually this problem. They tend to actually bully the people who are different. And then there are other stakeholders represented as roles: Asperger's mentors and a development team for the game. Okay, and now we have just about enough information to start creating a goal model for your products. And And here is the notation that you should use whenever possible. This kind of rectangle stands for functional goals, the cloud for to be quality goals, heart for to feel quality goals, the stick figure for roles, not for actors as in UML, but for roles. And then we represent the relationships between goals like this, and relationships between goals and quality goals like that. But it's not that important. I mean, it can be just a line. I mean, it's not. I'm not like a bureaucrat in this sense that it has to be this way and no other way. This we already saw. So the exercise for the last hour today is create a goal model for the product idea of your team, starting with the purpose of the system that corresponds to the value proposition. And include relevant quality goals and roles. And just to help you, I repeat that the way we do it, well, we relate both quality goals and roles to the highest possible functional goal, meaning that here, for example, I've related the societally quality goal to the perform shopping functional goal, and this means that societally applies to perform shopping and as well as to all of its sub-goals. So the same thing is true for roles. The customer is a stakeholder, customer is required for achieving perform shopping goal as well as is required for achieving all of its sub-goals. But on the other hand, for example, here, this Asperger's mentors is related to that sub-goal, demonstrate creativity here, meaning that this role is relevant only for achieving that particular sub-goal, but not relevant to achieving the rest of the goals in this goal model. And the same principle also holds for quality goals. Okay, so and well, you can use an A1 paper, or you can use Microsoft Visio stencils for agent-oriented modeling, and this is where they can be downloaded. They are in the zip format, so you can download them and use whatever you prefer. I mean, it's up to you. And after this hour, then I'm looking forward to some presentations here, as you have done also in the previous weeks of this summer school. So I would like to see this goal models, at least from some teams. So, and this, I think it will help you, because it will reflect back to your business model later on. You will see it. So try to now start with conceptualizing your product in the form of a goal model.